Hello everyone, I welcome you in physics classes. Dear students, in my last lecture I have discussed about dual nature of radiation. Students, we have discussed about photoelectric effect as well as the photoelectric equation given by Einstein. I hope that previous topics are clear to you all, and today we are going to start our next topic, which is wave nature of matter. Students, as you know that the name of our chapter is dual nature of matter and radiation. In first chapter we have studied dual nature of radiation, and now we are going to start our chapter number 2, in which we will study dual nature of matter. Students, obviously matter has a particle nature, but what is a new thing which we'll study, that the wave nature of matter, that matter is behaving as a wave. I hope you are clear with the difference between wave and nature. Okay, so let us study the wave nature of matter. But first of all, what are those observations which lead to duality of matter? What are those observations? What provoked the scientists to study about it, to discover more about it? So students, there are 2 points which lead to the duality of matter, that are whole energy of this universe. Whole energy of universe is in the form of matter and radiation. Second, nature loves symmetry. If radiation got dual nature, then matter should also have dual nature. Okay, and the wave which is associated with matter. Now matter is behaving as a wave, so one wave will be associated with matter, and the wave which is associated with matter is called as de Broglie wave. Now students, if wave is there, then wavelength would also be there. So the wavelength which is associated with de Broglie wave is called as de Broglie wavelength. So once again I am telling you, de Broglie wave is nothing but it is the wave associated with matter. Okay, and the wavelength associated with this matter wave or de Broglie wave is called as de Broglie wavelength. Students, you can call it de Broglie wave also, and you can call it matter wave also. Okay students, I hope it is clear to you. So now our next 2 topics are very important from examination point of view as well as a competitive point of view, that expression for de Broglie wavelength for photon and for electron. Very simple derivations. So let us proceed. Expression for de Broglie wavelength of photon. Students, what is photon? Photon is the particle of light. Photon is a particle of light. Okay, so we want to calculate de Broglie wavelength for this particle, means for photon we want to calculate. So as we know the energy of photon, I have taught you about the properties of photon. E is equal to h nu, where E is energy, h is Planck's constant, and nu is your frequency. Give it equation number 1. Okay, after that momentum also we have studied. It is h nu upon c, where c is the velocity of light in vacuum. Okay, so P is equal to h nu upon c, but h nu is equal to E, so P is equal to E upon c. From here E is equal to PC. Students, E is equal to h nu in equation number 1, but E is equal to PC in equation number 2. That means comparing these both, you can write h nu is equal to PC. Nu is frequency, and you know in plus 1 class you have studied, in 9th standard also you have studied that frequency is equal to speed upon wavelength. Or you can you may remember the expression you have studied in 9th standard, the speed is equal to frequency multiplied by wavelength. Both are same. From here frequency we have calculated. Frequency is equal to c upon lambda. So it is your hc upon lambda is equal to PC. Students, c on the both sides, so this c will cancel out. Okay, so what will be lambda? Lambda will go up, p will come down. So lambda is equal to h upon p. Okay, so we know p is equal to mv. Momentum is a product of mass and velocity. So P is equal to mv. So lambda is equal to h upon mv. So students, this is the de Broglie wavelength for photon. Now, next we will study de Broglie wavelength for electron. So, let us proceed. De Broglie wavelength for electron. Students, sometime this question is asked in exam that find the de Broglie wavelength for material particle. So whether in exam it is coming material particle or for electron, the expression will remain same. Students are getting confused that now material particle, whether we have to go for that or this. So students, you know that photon is not a material particle. Photon is the light particle and electron is the material particle. So de Broglie wavelength, earlier we have calculated lambda is equal to h upon mv. But students, if electron we are taking, then let m is the mass of the electron and it is moving with velocity v, then what is its energy? Energy is equal to half mv square. So v square will be 2 will go up, m will come down, 2e upon m. So what will be v? Under root 2e upon m. Students are writing under root up to 2e only, but it is whole under root. Okay, whole under root 2e upon m. So you need to draw this under root little long downward side. Okay, so this is the velocity. So this velocity we have to put back in equation number 1. So whenever you will put it back, you will get this expression under root 2e upon m instead of v. This m will go inside, it will become m square. बिकॉज यू नो एम स्क्योर जब अंडर रूट से बाहर आएगा तो एम बनेगा, अगर अंडर रूट के अंदर जा रहा है तो एम स्क्योर हो जा रहा है. दिस इज द सिंपल स्क्वेयर रूट. ओके, सो एच अपॉन 1m will cancel out with 1m, 2me. Students, here E is your energy. So in terms of potential, if you want to write your energy, then E is equal to EV. Now here this V is capital V. It is not velocity, it is potential. Students are doing mistake here. What they are doing, they are writing small v in place of capital V. Here it is small v, velocity. Here it is capital V, means potential. So put this value of E back. So 2m instead of E, EV. So students, this is the final expression for de Broglie wavelength for a material particle or electron. Now there are some constants whose value we can put here. So the constant H, Planck's constant, 6.62 into 10 raised to power minus 34 joule second. The value of mass of electron, 9.1 into 10 raised to power minus 31. The charge on electron E, 1.6 into 10 raised to power minus 19 coulomb. Okay, so by putting these values back in this equation, you will get this expression. You can calculate it. If you don't want to calculate it, just keep in mind that our answer will be 12.27 into 10 raised to power minus 10 meter upon under root V. Students, 10 raised to minus 10 meter, if you remember in plus 1 class you have studied, it is 1 angstrom. So 1 angstrom means A के ऊपर है 0. This is angstrom. So your final answer is 12.27 upon under root V angstrom. Okay, so these are the two expressions for de Broglie wavelength of photon and de Broglie wavelength of electron, and both are very important because it is definite that these will come in exam, whether in series A, B or C. Okay, sometimes in A series they will give for photon, in B series they will give for electron. For photon it is very easy, for electron also it is very easy, but little terms you need to keep in mind, just like energy is equal to electron volt. Okay, if electron is accelerated to a potential. So these are some points about wave nature of matter. I hope you all understood, but still if you have any query, you are free to ask me. Okay students, now do write these topics in your notes notebook. Okay, so this is enough for today. Thank you. Have a good day.